Hey everybody, welcome back to Solidity Fridays. It is so good to actually start these again. We will be doing them every week from now on. It is a partnership between Linum Labs and Web3 Sanctuary. So we're very excited as to all of the episodes that are coming and everything that we get to dive into and explore. So on call with me today, I have Tamara Ringas and Paul Berg. So Tam and Paul, do you guys want to give yourselves a little intro?
Sure. Samara, you might have seen me in previous episodes. I'm a Solidity developer, and I'm also starting to get into zero knowledge a bit. Oh, I'm also
Cool.
an instructor at Web3 Sanctuary for the Solidity courses and the one cryptography course.
Yeah. Paul?
Hi, my name is Paul Berg. I'm co-founder and Solidity lead at Sablier Labs. We're building a token streaming protocol called Sablier. We've been around for a while. We launched V1 in 2019, and Solidity Fridays had actually covered the V1 a few years ago, and I absolutely love that video. I've been sharing it with any developer interested to learn how V1 works at a high level. So very glad to be here and now talk about V2, which is our latest release we announced a few weeks ago.
Yeah, amazing. So this is part one of if depending on however much we get through today, this can be a series of just diving into everything. So yeah, I'll hand it over to you, Tam, and the screen sharing here.
So yeah, am I right saying Sablier or is it Sablier? Or does it not matter?
It's up to you. The actual word means hourglass in French, so technically we should say Sablier, but we are speaking English, and so Sablier is fine.
Okay, cool. Thanks. Yeah, speaking of the hourglass, so yeah, you can stream tokens with this protocol over periods of time, and they've already done over $1 billion volume of streams, which is 38,000 streams, which is so cool. But yeah, with version 2, there's a few new features that we'll hopefully outline soon. And my favorite one is that you can do these streams non-linearly, so you can have stepped releases or any shape that you want to make. And that's what the hourglass makes me think of, which is really cool.
Thanks, that's right. We have quite a few new features in V2, and features which, as far as I know, we are the first to introduce, not just in crypto, but in the entire tech world. And the nonlinear streaming is the most important one and the most exciting one for sure.
And you also have the now streams NFTs. Do you want to talk about that a bit?
Yeah. So V2 is innovating on V1 from a couple of angles. But before we dive into those nonlinear streaming and NFT features, let me just, for the audience, just briefly explain how Sablier works. We are the pioneers of what we call lockup streaming. And lockup means that you make a one-time deposit into the smart contract. It's a singleton smart contract, so everything is all the streams are created in the same contract that gives user security and peace of mind because there are no deployments to make. It's everything under the same system, which was audited once. And once you make that deposit, every second, a small portion of that deposit gets unlocked to the recipient. It's a simple design. It works very well for use cases like vesting, payroll on chain, where you have a DAO who has a multi-sig, rather than having to make monthly payments, which are gas expensive, and labor intensive. They just create a one-time stream, and then for 1 or 2 years, the recipient can claim every time. So it's win-win for all parties. So that's what we do. Nowadays there are multiple types of streaming available in Web3. I just wanted to clarify what is our model, like the way streaming works in Sablier itself. And V2 has basically doubled down on this lockup design by saying how can we make it more flexible? How can we make the protocol more integratable and more flexible? And we realized, look, every stream is a unique payment. Like it has its unique characteristics. It has a special deposit amount. It has a sender and a recipient. It has a start time and an end time. Our streams, by the way, are closed-ended, which makes them autonomous. You don't need to monitor them. I don't want to name names, but with our competitors, you have to monitor them over time. Otherwise, they get liquidated. Not the case in Sablier. They're fully autonomous and permissionless and decentralized. Anyway, so we thought, I mean, NFTs, right? Like, let's wrap each stream. When you create a stream, every stream is associated with an NFT that the protocol mints for the recipient. And that unlocks an open, design space for like financial NFT integrations, because our NFTs, unlike the vast majority of them, are not just looking nice or pretty. You actually have this SVG, we will show in a bit perhaps, that represents visually the stream, but they also have underlying value. If I have a stream that has 10,000 USDC, you can use that potentially as collateral, because somebody knows that some portion of that USDC has been streamed and more tokens will get streamed over time. So basically, the NFT opens Sablier for integrations with DeFi, and that was the goal. And the other big feature we have in V2, and this is, I think, where is the biggest innovation that we brought to the market, is what we call lockup dynamic. Lockup dynamic is a new smart contract that we built, which lets users specify a custom streaming curve. So if in V1, every stream had this, when you created the stream until the end of its time, the payment rate per second as a mathematical function stayed the same. In V2, you have the ability to basically create any mathematical function. And as I've said, I think we're the first in the world to do this. The idea here is, the use case here is creating new incentive structures, or porting traditional monthly-based or weekly-based payment setups, payment contracts on chain in an automated fashion. And with the first use case, imagine you're a DAO and you want to incentivize your contributors, but you want to do it in such a way that you incentivize long-term collaboration. So you set up what we call an exponential stream that in the second to the third year, it gives the user double as many tokens as the first 1 year or the first 2 years.
That's such a good idea.
And so, thank you. Yeah, and we're excited to see what people will use it for, because because you can create any function. Basically, it's up to the developer community to give us inspiration for curves. Yeah, and the other use case I mentioned is traditional payment schemes. So in TradFi, you have all kinds of like monthly salaries. In the US, there's like 2-week salaries. Vesting contracts, they're typically monthly based. So I said, look, if we have this, we call it the universal streaming engine. V2, we call it the universal streaming engine, a bit pretentiously, but why not enable any kind of use case, right? So with V2, you can actually port over your traditional payments, and it will still be streamed. It's just that the time unit will be a week or a month.
That's really cool. Cool. So here's the repo. It's a very impressive repo, and it was very well audited. I think you got like 6 audits done.
7, yes.
7.
But close. We had 2 big audits from Cantina, Zaka Brandt, and the team were absolutely fantastic. Yes, we spent actually. So the audits are one thing, and we're happy with the results we got. But we're more proud of our testing infrastructure. I don't know if you had a look at our test.
Intense testing.
Oh yes. We spent 15 months building this.
Wow.
We have categories for everything. We have a bit of an OCD about how clean the repo is, how organized, how structured it is, and I actually had a presentation about our test infrastructure at ECC,
yes,
where we can maybe share it in the show notes after The idea, I talked about what is the logic behind the structure, why it is useful, how it has helped us, and so on and so forth. And then I dive deep into each test file, how we structure it, and in case you have seen these tree files, I've also presented these branching tree, what I call the branching tree technique, which is a minimal specification language. Again, that's a bit pretentious as well, but it's a nice way to organize your tests and reason about them in using plain English.
Yeah, definitely check out that talk. We'll put it in the description on YouTube. I also love that you did invariant testing, as well as like you did every type of testing you needed to, but invariant is not very common, especially like done in Foundry. It's quite a new thing. So I'm very excited to look at these. But I don't think we'll start with the tests today, but that could be a whole series of its own because these are really impressive tests to look at. I've been learning
Thank
from
you.
them.
And I absolutely agree. Invariance tests are the most powerful tests available today in Foundry. They're basically system level invariants where we say that, think about what are the implicit assumptions in your protocol, and you want to basically test them in such a way that Foundry generates like these long hundreds or thousands of calls, random calls, and then after every call it says, do all of your invariants still hold? So it's super powerful to catch non-obvious system-wide bugs.
Yes, yeah, it's a really good testing technique. Yeah, there's the Satora prover, and I was reading something yesterday on how with Dai there was an issue that they found only right at the end in one invariant test. So I love invariant
Satora
tests.
is great, by the way.
Yes. So yeah, as we've mentioned, it's made in Foundry, so it's mostly Solidity code.
100% built with Foundry. Yeah, the
So
backend.
cool.
Yeah.
And yeah, you can install it with Foundry, or if you want a Node, it's also a Node JS package, which is really cool. I definitely want to do an integration with it with one of my projects. Awesome. Oh, and maybe we could talk about the license a bit.
Oh yeah, I mean, this is pretty much we inspired from Uniswap. We spent years building this, and we believe that the core streaming logic, that's the only thing that is business licensed. It's basically to build a commercial application, as in like if you want to fork it, you have to ask for permission. But otherwise, if you have like an integration with us, you only need the interfaces, fully open source GPL. If you want to use the test, they are on license. You can do whatever you want with them. If you want to learn from them, copy them. It's fully open source. And also, we're also very active open source developers at Sablier. So part of the V2 core and V2 periphery, so the Sablier V2 repositories, I personally shipped two other Solidity libraries called PRB Math and PRB Proxy, which are MIT licensed. You can do whatever you want with them, and they're actually very useful for doing on-chain math and on-chain composition of contract calls. And that's also something that we basically, because I'm a core like Sablier builder, I contributed to the open space, to the like open source ecosystem in DeFi. So the only thing that is business licensed is the core lockup linear and lockup dynamic streaming logic.
That's a really good idea. And then that'll become open source later on here.
Oh yeah. So once we grow for the next 3 years or something, eventually then even the streaming logic itself will turn into like GPL, and it will be free forever, free to fork, free to do whatever you want. It's just for 3 years.
Good. That's great. Yeah, that's awesome. Just on PRB Math, I use it all the time. It's my favorite math library in Solidity. I've even used it in production on 3 different projects.
Awesome. Yeah.
Yeah.
Well, good to know that we had it audited. And yeah, just very glad to hear that. I spent quite a lot of time crafting that library. It was a work of love for me to build a math library. So very, very, very glad to hear that, to like meet a user.
Yeah, thanks. I really find it makes my life easier. Would you like to discuss anything else that's new in V2, or would you like to dig into the code next?
Um, just to clarify maybe the NFT design we talked a bit at the beginning, just to give people a visual hint for how they work, and then we can talk about the code behind it. So if you go to our docs, if you go to concepts, top left, there is the NFT section, and here are some pictures. If you scroll down,
Oh, cool.
yeah. The idea here is that this is inspired by Uniswap v3 positions, and this is an entirely on-chain generated SVG. Whenever you hold a Sablier stream in your wallet, you'll see this. If the wallet that you're using supports SVGs, OpenSea supports them, so you can see them there. And actually, if you scroll even further, you'll see a gallery of how multiple streams look like. Each one of them has different colors, different cards. So the SVG actually updates in real time. I think this is the first NFT in DeFi which has real-time properties whereby some things inside it, the SVG, change with block timestamp and various user parameters. Even with Uniswap v3, it only changes when you make a deposit or like when you withdraw something. These are the most dynamic NFTs in DeFi as far as I know, because they change their values. If you see the progress cards at the bottom.
Yes, this one's on 100 and this blue one is on 0.
Yeah. Yeah.
That's so cool. Wow. I love dynamic NFTs. We once did a whole episode on one, so it's just cool that it's like an Easter egg. You already have this really cool streaming platform, and now you also have these dynamic SVG NFTs. It's awesome.
Thanks. Well, we have to bridge the technical parts with the bigger world of like people who are not necessarily developers, right? And this is a platform to give people a hint about what's happening. Like why is it streaming? Well, we have the status cards, the progress updates in real time, and the nice thing for like us developers here is that everything is Solidity based. Was quite fun we can go over the code in a bit, but it was quite fun to hard code SVG HTML in Solidity and try to make it gas efficient because we paid a lot to deploy this, but anyway.
I can imagine. That's really cool. Awesome. Oh, and then there's also hooks in V2, which I'm excited about. So you can get notifications from on-chain events if the stream reaches a certain status, or some streams are not cancelable. Yeah, cancelable. So if a stream were to get cancelled, then the hook would let you know. So that's also an exciting new feature. I think it's new.
Precisely. It is new. It wasn't in V1, and what you said is exactly correct. The idea is, as I've said at the outset, we designed V2 to be maximally integratable. And if you are building, for example, an NFT lending protocol where somebody puts one of these hourglasses into, for example, Astaria, and they want to draw some tokens as a borrow, then what happens if the stream is canceled, or what happens if somebody withdraws from the stream? The protocol must take some action in response to that interaction with the stream. So hooks enable you as a Sablier integrator to respond to on-chain events in the same transaction as the stream user makes that initial transaction.
Amazing. Wow.
Cool. We have one question. Let me show it here. It is, what is the main differentiating feature between Sablier and Superfluid? Maybe
That's a good question. And I've actually received this question so many times that I think we should put like a page on our docs. So superfluid is open-ended. That means that when you create a superfluid stream, it will run forever until you either close it manually or their liquidation network closes it for you. And you will be charged a fee, by the way, if your superfluid stream gets liquidated. Sablier streams are closed-ended. They have a start time and an end time. And you can see it visually with our hourglasses. We have a well-defined deposit amount, and the benefit of this is that they are autonomous. We have zero off-chain components in Sablier V2. Everything is on-chain. Everything is permissionless. You don't need to rely on any liquidation system to close the streams. And there are pros and cons for each streaming model. What I would say up front is that Sablier V2 works better for cases when you have the tokens up front, and our most popular use case is vesting. So imagine you set up a token in DeFi and you want to stream it to your investors, to your founders, to your community. You know how much you want to give everybody. Setting up a Sablier stream once just works, and we argue that Sablier is the better solution for that. Superfluid might work better for things like payroll, where you have an employee and you don't know when they will leave the company, and you just want to keep the stream going forever. But at the end of the day, both can be used for either use case. It's just that, like what I said, is what tends to happen with our users and their users, where they gravitate towards. I hope that this answered your question.
Yeah, thanks. I think it's very clear. Awesome.
Yeah, thank you.
Yeah, both great protocols, but slightly different use cases. Cool. Would you like to start digging into the code?
Sure.
Yeah.
Let's start at a very high level. What files we have in source. There are 4 contracts. You have the controller, you have the lockup dynamic, you have the lockup linear, and you have the NFT descriptor. The controller is an on-chain configuration module for setting fees. Basically, for setting fees, that's the main use case. We actually have a 2-tier fee system where it's called protocol fees and broker fees. Protocol fees are a global fee applied to all the streams, which is currently set to 0, and it will remain set to 0 for a long time because we want to promote the growth of the protocol. But the broker fees are actually a source of revenue for Web3 developers or companies looking to integrate Sablier, because the idea there is when you create a stream, you can specify your address and your a percentage, which will be basically your on-chain revenues derived from your integration of Sablier. And the controller basically manages certain key properties about these fee systems, for example, the maximum limits and this kind of thing. The lockup contracts are the core streaming logic. That's where you make the deposits. That's where the tokens are held. And that's where create, cancel, withdraw from streams, and so on and so forth. And the NFT descriptor is in charge of generating those dynamical NFT SVGs that we showed you before. And yeah, it's full of SVG code, and it's an entirely stateless contract. All it does, you pass it a Sablier stream ID, and then it spits out that SVG.
Awesome. And what libraries have you got going on here?
Actually, those are just local libraries.
I see.
The big library used in V2 is PRB Math, which is external. That's on lib if you want to have a look.
Yes.
Here you only have a couple of helpers. Those helpers are basically just checking user input parameters. And errors is where we
Okay.
store centralized all of our custom errors. For those of you out there who are still using require revert strings,
Yes.
please upgrade to custom errors. They're much more gas efficient. Don't make your users pay unnecessarily high gas for errors. They are already pissed that their transaction failed. At least make them pay less with custom errors. And yeah, then
Yeah, I
finally you
agree
have
with
the
that.
SVG libraries.
Okay, cool. I'll check that out one day. Where would you like to start with the core code? Would you like to look at one of the lockup contracts maybe, or the NFTs?
Let's go over the lookup linear interface. If you go into the interface folder.
Tom, could you just be sure to zoom in a little bit, just so everyone can see the code? I think it's a little small.
Yeah, I definitely will, sir.
Cool, thank you.
Awesome.
Yeah. What I want
Cool.
to explain here first is that we are keeping our source code documentation in the interface class. And the benefit of this is that you can reuse your documentation in multiple contracts. For example, if you have an abstract contract that is inherited by multiple contracts, you can say the documentation for this function is inherited from this abstract, and that lets you reuse documentation. And yeah, the interface is where we define, how this can be used by integrators as well. When you would create, for example, a dApp which creates streams, you would import this interface into your, Foundry project or Hardhat project, and call the functions that you can find here. So if you would scroll now, you will find the create functions. This is the event. Okay. Yeah. This is where it all starts. There are two functions for creating streams. And this is an improvement over V1. In V1, we only had one function which required users to pass a start time and an end time. That caused trouble with DAO integrations, whereby people were creating like a proposal. Hey, I want to use Sablier for this, and they were saying the start time is this and the end time is this. But until people were like signing and voting on the proposal, the start time was in the past, and the transaction was reverting, and many bad things were happening. We still have that range function. We call it creative range, is below. But at the top, you have creative durations, which we think is the most user-friendly function for creating streams. Because the way it works is you specify a duration in seconds, and then the start time of the stream will be set to the current block timestamp when the transaction is eventually mined. And this works just absolutely great for DAOs, because they can say, I want this stream to last for 2 years. I don't know when this transaction the proposal will pass. But when it will eventually pass, then the function will set the block timestamp at the time of inclusion in the blockchain, and that's it. And yeah, if you scroll to creative range, one thing we like about our documentation is that we are very explicit about what you have to do to create a stream. We have all of these requirements, and each one of those is like tested. And yeah, just we believe this is the way to go for like financial contracts. Like every single requirement should be like laid out very explicitly.
Yes.
One other thing maybe worth mentioning here is that we're using structs for the parameters. We didn't necessarily want to do this, but as everyone on this call should know, there's this issue called stack too deep in Ethereum and Solidity, and you basically can't have more than 16 variables on the stack. So with structs, you can hack around that by using memory pointers and whatever under the hood, and That's what we do here. But the structs themselves are also quite well documented in our website. I think you were looking at the lookup linear page before.
Yes.
All right. So like from here, I think we could go to the actual, let's see how, create with
Cool.
durations work in the implementation contract.
Stunning. Oh, nice ASCII.
Yes. This is both branding and honestly just user discoverability. So when you go to Etherscan, you see the source code verification. The contract name is like this tiny attribute on the page. With this, it's like big, you know what you're looking at, and so on and so forth, and just looks cool.
Yeah, I love using ASCII.
Yep.
Awesome. Something else I've never seen before, but I really like. Oh, sorry, I forgot to turn that off. Is here you say how many inherited components there are for each inherited, contract or interface. It's really clever. It's exactly what you're getting into. I like that.
Thank you. And there is actually a good reason for this. It's not just, it's helpful in and of itself, but in the Solidity documentation, they have this best practices recommendation that contracts should be inherited in the order of most base-like from most derived. And base-like means you have fewer, so the contracts you are inheriting, they have fewer dependencies themselves, and most derived, they have more dependencies themselves. And it's actually quite a subtle point that is often overlooked, that people just assume that the inheritance will be figured out by the compiler, but inheritance, like the order of inheritance actually matters. It can lead to very ugly bugs or like compiler errors that are hard to debug. And oftentimes the solution is to just apply that principle of like most base-like to most derived, and using comments of like how many parents, how many dependencies that contract you are depending on has, is a clean way to stack them up in the right order. What I will caveat here is that maintaining these numbers can get annoying. I've been talking to the Slater team trail of bits about this to try to. I think they have a feature where you can pass a path to a contract, and then they will say like a succinct print of what are all the inherited components of that contract itself. So maybe in the future, that can get automated in the sense that it can run like a CLI tool and it will spit out the number of parent components. But for now, it was manual, but well worth it for our setup.
Yes, definitely. That's great. Cool. So it inherits the interface and then Sablier v2 lockup. So is that like a generic lockup that both inherit?
Yes, we can actually go. I'd like to go over that after we finish with this contract, because Sablier v2 lockup is basically a shared logic between lookup linear and lookup dynamic. For example, both have a withdraw function, and there's not much point in like the same implementation. So we put it in these abstract contracts. In case you missed them, abstracts are reusable contracts that cannot be deployed themselves, but they can contain logic. So they're like something in between interfaces and contracts, where you have reusable logic, and that's where we put the shared logic between lookup linear and lookup dynamic. Yes.
Awesome. Cool. Then you have a mapping, which is called streams, and it goes from an ID to the struct of stream.
That's right.
Why did you make that private?
Well, it's really a minor point in the grand scheme of things. We could have just set it to internal and the effect would have been the same. The logic was, suppose for whatever, suppose in like future iterations of the protocol in like v2.x, v2.1 or whatever, we we further develop the protocol, and we extend it in some way, or somebody extends it in some way. We don't want the most important mapping in the system, which holds, I mean, this is where the user funds are stored. This is where people's money and life savings are in this very mapping.
Yes.
So we just wanted to say, look, lookup linear is the only authorized entity in the system to touch this. Nobody else can, like not even children of lookup linear.
Okay. Yeah, that's great. Thanks. Cool. Do you want to walk us through the constructor? It's a pretty simple one.
Yep. As you guys know, the NFT, Sablier streams, V2 streams are NFTs. So to do that, you need to inherit the ERC721 interface. We use Upland Zeppelin. We didn't code it ourselves. And we, pass the name. It's lookup linear NFT. This will show up on OpenSea, by the way, and that is the NFT symbol. And then we pass the Sablier V2 lookup abstract constructor to set the initial admin, the initial controller, which holds the on-chain configuration for fees, and the NFT descriptor. All of these parameters for transparency are changeable, but the contract itself, lookup linear, is not. It's not upgradable. It's fully permissionless, and the way you see it here, it will remain until the end of time, until Ethereum runs basically. And yeah, the only thing we do in the constructor is we set the next stream ID to 1. Why we set it to 1 and not to to 0? No particular reason, just preference.
We just want to.
Yeah. It's more human friendly, I guess, rather than starting at 0. I know we developers typically like 0 indexes, but streams will be managed by humans, not just by machines. So
absolutely,
starting at 1, yeah.
Cool. Then there's some getters with some modifiers, which I assume was in that shared abstract contract.
Yeah, exactly. Okay. Yeah. The idea is we employ an approach. We have a philosophy of fail early, fail fast. And even for getters, if you are trying to interact with a null stream, you are not allowed. You will get a reverts, and that's it. Sorry for that. What I wanted to mention here is the connection between the previous interface and what I said about reusing NASDAQ comments. So because we have the abstract Sablier V2 lookup, what we can do, and so we actually also have an interface. Sablier V2 lookup. We can define the interface once, and then in both lookup linear and lookup dynamic, and the shared getters, we use the inherit dog feature of Solidity to say all those NASDAQ comments will be inherited here.
That's great.
And one other thing I wanted to mention here, just as what I think is a best practice, is that we separate the constant functions from the non-constant functions using these headers. As you can see, I like to call them user-facing, not public, not external, because there's actually a technical difference between the two of them. So we came up with this term which is more generic than either of those two terms. So user-facing means basically either external or public.
Okay, great. Yeah, that's great. So you can get an asset if a stream is not null. You can get a cliff time and get the deposited amount so far.
Yep. And these are like boring getters. All they do is they read from the private structs.
I see. This is how your range works. It's a struct with a start, which would, I guess, for the one be block.timestamp when it goes live, and then
yes,
cliff and end. Okay, cool.
We can briefly go over the data types in the types directory just to show you how the storage layout looks like.
Yeah. Would you like to do that now? Or do you want to finish this contract first?
Let's finish this contract and then we can go over those data types. Yeah.
Awesome. Cool.
So just getters.
Cool. Get stream from stream ID. Withdrawn amount. Is it cancelable? Cancelable. Sorry.
Yeah.
What does it mean if something is cold?
Good question. And I think we have a diagram. So if you'd go to our docs, it's the easier way rather than me trying to statuses. If you scroll here, there should be a diagram. Here we go. Yes, we have it.
Okay, so it can
I'm
either
so
be
glad we have it
settled.
because
Yeah, it's a
this would
nice
have been
graph.
hard to explain with words. But the idea is, a Sablier V2 stream can be in 5 different statuses, and they're mutually exclusive. They are either in one of them or in one particular status, or they're not. We're using an enum for this, and because there are 5 statuses. We wanted to group them further into 2 higher level categories because we needed those higher level categories for access control. So for example, some actions like withdrawal can only be made on some particular statuses. Canceling can only be made on some particular statuses. For example, you cannot cancel a canceled stream. You also cannot cancel a depleted stream because there are no assets left to recover, to get refunded. So we classified those under the name of cold. So the cold stream, there's nothing from it anymore. You can wait until the end of time. The stream has finished and it's cold. On the flip side, you have warm streams, which are streams that are either streaming. We were not that creative when we thought about the name for that status, but it works. It's like super clear. Or like pending, which is the stream was created but has not started yet. So if you use creative range, which is this function where you can specify the start time in the future, you can say, I want the stream to start in December, and now it's July. Well, the stream is pending. Eventually it will start trimming and assets will be released to the recipient, but now it's pending. And we call these 2 states warm because there's an expectation that some assets will be unlocked, streamed at some point in the future. Cold means that nothing will ever be released from the stream. The recipient has received everything.
Okay, that makes sense. Thank you. And I assume with cold state streams, this is when the NFT goes gray. But we'll see that when we look at the NFT later, I guess.
You said when the NFT goes gray?
Yes, well, like in the pictures here, there's like colors for each NFT state. And this one, is it per thing?
It's
so like,
just
is this always a gray
coincidence.
NFT? Okay, my bad. I read into
So
something that wasn't
the
there.
way it works, you get assigned like a unique color when the stream is created.
Okay,
but no,
and it doesn't
it's
change. Okay.
Yeah, it's an interesting coincidence that final color is gray, but it's just a coincidence. Yeah.
Okay, cool. Thank you. Cool. More
No worries.
getters.
Yeah, we have a lot of getters. If you make an integration, you can query every single part of the stream.
That's great. And now we get to a really exciting, actually creating a stream. This is with the durations, not with the range.
Yeah, we can go over this one because it's, as I've said, the more useful one, especially for DAOs, for on-chain organizations, and so forth. The idea here is that you specify the duration in seconds. And actually, sorry to muck about with you, but I think it would be useful to open in a separate tab the data types, because we should start with explaining the parameters first, which are so if we go there, I wish we were able to keep them there, but back to the got in the way.
No, I clicked on it. I'm so sorry. Let me just do this.
Yeah, great. Cool. What you can see here is that we're using libraries to namespace the types. There are 3 namespaces. It's lookup, lookup dynamic, and lookup linear. What we want to do now is look at lookup linear create with durations.
Okay.
Yeah, it's here. It's here. Yeah, I think my internet connection is.
I think that might be. I think it's 10 because it's also a little bit slower, but
No, unfortunately. Can you hear me though?
Sorry.
Oh,
So it's a struct.
I can see it now. Okay.
Oh, okay, wonderful.
Yep. It is a struct, and you have 7 parameters. You have a sender, you have the recipient, you have a total amount, an asset, a cancelable boolean, a duration struct, and a broker struct. The sender is the account, which typically is the account which funds the stream. It doesn't have to be the same account. It can be somebody else can fund the stream and assign somebody else a sender, but they're typically one and the same. And the sender is the account which can cancel the stream if you make it cancelable.
I see.
The recipient is kind of obvious. It's the person receiving the tokens. Total amount is the ERC20 deposit, inclusive of any fees. So the broker fees and the protocol fees will be taken from this amount if they are set. The asset is the ERC20 token contract address. Cancelable lets you specify whether you want to retain the ability to cancel the stream at some point in the future. And durations is a struct with 2 variables. If memory serves me correctly, it's cliff and total.
I'm trying to find it. Oh,
It
yeah,
should be
total,
it should be
you're
here.
right.
Here we go. Yes. And they are UIN 40 for gas efficiency purposes. 2 to the power of 40 is enough space for timestamps. I do believe that Sablier is here to stay and built to last, but I think something like 3 billion or some 4 billion years is enough for our needs. Anyway, yeah, so the idea here again, you specify 2 years total streaming, and then you can say optionally for the first 2 weeks, 1 month, whatever, no streaming should happen. This is like an optional add-on. If you set the clip to 0, then the stream will start right away at the start time.
Okay, cool. It's great to have a cliff, especially for vesting.
Exactly. Yeah.
Cool. Should we pop back to this?
Yep. Let's go for it. Okay, so as I said, the create with durations sets the start time to the block timestamp. And then what we do, we calculate the range, because eventually you have to get like a well-defined range. That's all lockup streaming is about. You have like a well-defined range. So we calculate dynamically the start time, the cliff time, and the end time based on the user provided parameters. And we just sum the start time and the durations provided by the user. We use unchecked because the helper functions in the helpers library will check we check that the times are ordered anyway. Okay. And we proceed with calling internally. What we do is we call the shared internal function called create with range. So in a way, create with durations is like a front end for an internal create with range. If you know that meme with the Scooby-Doo character who has like what do you call it, like a sack on their head, and they're like unveiling the evil guy, then creative duration is actually creative range under the hood, and we create like a runtime struct where we specify the calculated range as the range parameter. So we can go to the creative range function now, which is at the bottom, at the right at the bottom of function of the contract.
Oh, there it was. Cool.
Yes. What I want to mention here very quickly is at the outset is that we have every single bit of logic commented. Some of these might seem superfluous, but our philosophy is that, look, these are financial contracts. We obsess about security. Like, we want to make every single piece of code explicit and think about them very explicitly with comments like this. So even simple stuff, or basic stuff like querying a constant function, which typically doesn't lead to any bugs, right? It's like querying constant functions. We explain why this is safe interaction. We say that the controller is a known Sablier contract, and we just query the protocol fee, which, as I've said, it's adjustable. It's going to set to 0. Then we validate every single user provided parameter. We track that. You can actually go to helpers library. That would be helpful to see the check and calculate fees and check creative range just very, very briefly.
Let me just
we also put them in a separate library because again, stack too deep. There were too many computations being done. But basically some simple checks. There are no 0 deposit amounts allowed. The protocol fee cannot be greater than a maximum hard-coded fee. And this is for user security, right? The broker fee, the same, cannot be greater than a max fee, which is a hard-coded to 10%. And the max fee itself cannot be changed. So that's why the security benefits come from. And then here's where PRBMap shines. We're using PRBMap to calculate the percentages. So the protocol fee is a percentage. So we say, it's 0. Suppose it was 0.1%. We would calculate 0.1% from the user deposit, and then that would be retained by the protocol as a fee, and then the remaining deposit would be streamed and returned in this function, and then used by the create with range internal function. And there was another function here called create with range, which was again, very simple checks, but necessary checks, like no 0 amounts allowed. The times have to be ordered, so the start time, the click time, the end time, and the current time. One fail safety mechanism is that we don't allow so the current time, the end time cannot be in the past, and the reason for this is we're like a streaming protocol. If you create a stream which has already streamed, that might be an accident. So we don't allow that transition to occur in the first place, and we make a revert. If you want to make like a payment to somebody, like a fully, everything in one go, then just make a near to transfer.
Yeah, that makes sense. Wow, lookup dynamic looks complicated, but let's head back to where
it is complicated. Yeah, it is a bit more. There's more code in there, yeah. But cool. So if we go to create with range, so we do the user validation. We're big fans of the checks, effects, interactions pattern, where you do your checks at the start, all of them, as many as you can. Then you do your effects, which are like state changing operations. And in our case, the big state changing operations, we create a stream. And this is a struct. We initialize all the parameters. We set the default. Obviously, just create a stream is not depleted because it has just started. The eStream boolean is used to differentiate null objects in the mapping from non-null objects. We could technically have used like some other property, for example, the deposit amount, which cannot be 0, but we want to have like a very well-defined flag which says this is a non-null stream in the mapping. And basically just like converting the user parameters into storage variables. And that's it. Then we proceed with bumping the next stream ID, which is just a counter we're using unchecked because streams cannot, counters which increase by 1 cannot realistically overflow ever. There's not enough ether in existence to, even if we were the most successful protocol in existence, like, billions of years would have to pass to get there or something like that anyway. So we do the increment, and then we add the protocol revenues. The final effect is that we mint the NFT to the recipient. And the stream ID is used as the NFT token ID.
That's clever. Yeah.
Finally, we have the interactions. There are 2 interactions here with external components. We first deposit the stream amount into the Sablier V2 lockup linear contract, as well as the protocol fee. So we sum them together. The final interaction then is if the broker fee was set, then we transfer the broker fee to the broker account, and it's on-chain revenues. So we, on a side note about this, we're big believers in revenue-based systems on chain. We don't have a token. We're trying really hard to build a business here, so that's why we have systems like this to like charge fees when you interact with the system. And this is also like a monetization pathway for our integrators. Anyway, sorry for that side note. And finally, we have the emit event. Yeah, basically just letting everybody know what happened, that a lockup linear stream was created. And this is, of course, useful for off-chain indexing, subgraphs, and so on and so forth.
Yeah, awesome.
And that was it with durations.
That's cool. Oh, sorry.
Amazing. We're actually reaching on the hour for
yes. Oh,
this
look at
stream.
that.
Yeah, so
Maybe
it's like great
just stop.
timing.
Thank you. This has been so interesting. I'm really enjoying going through this.
It's been a really good episode.
Same. It's nice to get to present your work after years of quasi-isolation. So thank you for having me. I think maybe we could just briefly show the abstract in the Sablier V2 lockup.
Sure.
Just to show you the shared logic. Just
Sure.
gloss over the high-level functions. So Sablier V2 lockup. Maybe we could continue here in the next part of the series, but here the idea is we don't have time to go over those contracts, but just briefly scroll over what's here. This is the shared logic between lockup linear and lockup dynamic, and just basically do the plumbing for the admin logic for the controller, the null checkers. We have this update metadata function because, as I've said, we are the first protocol to create like a real-time NFT. We actually have to notify NFT platforms whenever there's a change in the stream data, because that will push them to update the SVG. Yes. That's a story in of itself. But anyway, as you know, the recipient is the NFT owner, so that's what the recipient is actually requiring it from the ERC721 owner function. Various other getters. The token URI thing, this is where we query the NFT descriptor. We call the external contract, where the SVG is generated. And various other shared functions for canceling, withdrawing, and renouncing, which is the ability to renounce the ability to cancel streams in the future. It's kind of meta. But this was it as a first presentation into foray into Sablier V2.
Awesome. Such a cool protocol. Thank you.
Oh, I thank you. This was great.
Cool, yeah. And it will make this a series, so you'll definitely see more Paul and more Tam as well. Cool. Thank you so much, guys. The recording will be up on Friday, and we'll see you next week, Friday, for the next episode. Yeah. Thank you, guys. Bye.